Question B3 says a skier is pulled up a hill by a rope at a steady velocity. The hill makes an angle of 12 degrees with the horizontal. The mass of the skier and skis is 73 kilograms. The diagram below shows three of the forces acting on the skier. Okay. The first question says, on the diagram, draw and label one other force acting on the skier. Okay, the obvious force that's missing here, if we have reaction, tension, and friction, is the weight or force due to gravity. So I'm just going to draw that from what I consider to be a center of mass. And I'm going to draw it vertically downwards, and I'm going to call it Fg. Calculate the magnitude of the normal reaction acting on the skier. Okay, so for this one, I'm going to sketch a little vector diagram to help me calculate this. It's not going to be equal to Fg because they're not exactly in line. So what we're going to do is draw a Fg like that. And then I'm going to draw the normal reaction force like that. And then I'm going to draw the friction force like this. And then I'm going to draw the tension force like this. So all of those should cancel each other out. And we should, because it's moving at a constant speed. Okay, this angle here is going to be 12 degrees. And the reason that's going to be 12 degrees is that if you think about the slope, if the surface has been tilted 12 degrees from the horizontal, then the normal reaction must have also tilted 12 degrees from the vertical, if you see what I mean. And so we now know that we have a right triangle there. This angle here is a right angle. And we know what the weight force is. And so in this one we weren't told that G is 10. So in this one we'll use 9.81, given that that's what's in the data booklet. And so we know that the F normal, which is the adjacent side here, F normal adjacent divided by hypotenuse, Fg, must be equal to adjacent over hypotenuse is cosine of theta. And so Fn is going to be equal to, let me just move this down, Fn is going to be equal to Fg cosine theta. And if we plug in the numbers, that's going to be, was he 72 kilograms? 73, okay. It's going to be equal to 73 times 9.81 times cosine of 12. Okay, and that gives us, let's have a look. Just move this along a little bit. So it was 73 times 9.81 times 12 cosine is equal to 700.48. 700.48 newtons, which is about, for our purposes, we only want two significant figures, so we'll write 700 newtons. You could write 7.0 times 10 to the 2. That would technically be two significant figures, but that's fine. The total frictional force acting is 65 newtons. Determine the tension in the rope. Well, if we look back at our diagram that we conveniently drew above here, let me just go down, this diagram here, we can see that the tension force must be equal to the friction force plus this little bit here. And so, because it has to first cancel out the friction force, and then it has to also cancel out the horizontal component of the, or the downslope component of the normal force. And so, what we'll do then is, so this is kind of a tricky question, probably worth more than 2 marks, I would say. Anyway, I'll leave that down the bottom there so that I can see both the diagram and the question. So, F tension must be equal to F friction plus this other little force is equal to F friction plus F, what can we call it? We can call it normal reaction, normal, and let's just put a down arrow. So that's the downhill, along the slope component of the normal force. Okay, and so what that means is that we're going to have, it's going to be 65, so it's got to cancel out the friction, and it's got to also provide enough to keep the person in equilibrium. And so we want that side now, and we know that this is what we have labeled as Fn down, right? So that little bit is going to be Fg sine theta. So we end up with 65 plus, and Fg was 73 times 9.81 times sine of 12. So if we go back to our calculator, we get 65 plus 73 times 9.81 times 12 sine equals 214 equals 214 newtons. Okay, we only really wanted to two significant figures, so that's 210 newtons. Okay, last question. Explain using Newton's first law why the resultant force on the skier must be 0. Skier is not accelerating. Let me just move that down a bit. My pen isn't writing. Accelerating. So the net force by Newton's first law must be 0. Okay, or words to that effect. So you could say the skier is moving at a constant speed, therefore they're in equilibrium, the net force must be 0. You basically need the idea that it's not accelerating and the idea that Newton's first law therefore says that it should be 0. Okay, so that's the test. Bring any questions that you have about this to class, please. If I've made mistakes, then they're probably silly calculation mistakes. Let me know if that's the case as well.